Okay, so now we did a very basic pre-processing of the data. So let's maybe have a look at what we did and then continue with the GLM. Hello? So if you were doing this, what you should do essentially is after you did some pre-processing of a single participant and maybe of multiple runs of that, you should have a look at the images. And as I said, you can also, of course, automatize that using, again, the batch editor and how to write scripts based on that. So maybe we look at the last image or a random image, and I don't have to scroll forever. So the original one, then the one realigned one, a normalized one, and a smooth one, and let's say the single subject T1. Another one. Done. So, and again, you could write a script now based on that. And that was maybe not the best way to do it. The best way around to do it, because it now it's a little bit annoying. So you can do it in a better way, so that it's somehow. So the first one should, I guess, be a M&I template, and then it makes a little bit more sense. But anyway, so we have here the original one. It's also not labeled, so this is why I also at one point had an own thing, so that you actually always know what that is, but you can look it up if you right click. So this is the realigned one, this is the original one, and this is then the normalized one, where because it puts this in the center, things then start to get iffy. But you see clearly that this image here and this image here are not aligned, which speaks to the thing that this one here is actually aligned with the API, although again here, no, it looks fine. So the problem is, I think this is what we saw previously. So it's fine. You see the alignment has worked. This is the cerebellum. And this is visual cortex. It's just positioned stupidly because it's this is positioned in a good way. So we should have selected the images the other way around. The last thing that we haven't looked at yet is the smoothing. And as you can see, smoothing makes things more smooth, and it makes it quite smooth. So this is the effect of spatial smoothing. Yeah. So. Yeah, these are the steps that we took. So this is now the final one, the smooth, normalized, and realigned one. And on these, we now will do the GLM. Yeah, and from using this, you can, of course, as I said, also automatize this. But you should, at this point, actually also have a look at the images and kind of roughly make sure, like we did in this case, that the big anatomical landmarks, they are actually there where you want them. And if you have more API data than we have here, because we only have the stack, then it also might look a little bit nicer and you feel even more satisfied than you do now. So. Flödi. So then, well, maybe we do it differently here. Let's call this fMRI analysis. And put the GLM stuff also in here, because why not? This function is available for pre-processing and statistical modeling of fMRI data related. Pre-processing and then statistical modeling. GLM modeling. So, because then we can use all of this, and this was our data management, and this was our pre-processing. And yeah, so the classical way is that you first pre-process the data from all participants and then you do GLM modeling. But of course, you could also do the GLM modeling here. Doesn't really matter. The important thing is that you check intermediate stuff, yeah? So that you make sure that at least once you've done, I mean, if things don't work in the end, if you don't get any results, then you always ask why, and then you usually will start digging into these pre-processing steps and looking whether things work. So it makes sense to do that already while only doing the pre-processing. So now, however, we go into first the subject level GLM modeling, and let's get rid of that. And then have a new script, CB fMRI GLM first level subject level. So we put in another subfunction below that here. Let's take some of this with us. Did I call it? GLM subject level. For subject level, or participant level, I should say, not subject. I don't want to use the word subject anymore. does. So specifically, model formulation, of course, so we have to formulate the GLM for each voxel that we want to use. So we can call this model formulation or design matrix formulation. Let's call that model formulation. So the big thing that you see if you use SPM for FMI GLM analysis, it's all focused on the design matrix. The details of how the covariance structures actually created are not that apparent from the way you interact with SPM, but is fairly specific. So it uses, because the whole thing uses this restricted maximum likelihood estimation approach, it uses a covariance component approach, and as I said earlier, you find that in the paper with Ludger from 2017. If you want to know the details, the whole community focuses a lot on the design matrix creation and not so much on the covariance matrix creation and how it's estimated, because it's more hidden in the SPM functions. Then model estimation, and there you can essentially choose Bayesian or maximum likelihood, and everybody is using classical estimation. So this comes down to restricted maximum likelihood estimation in a, of course, voxel by voxel manner. And then we have model evaluation, which comes down to contrast evaluation. Yeah, so these steps should be familiar to you if you followed the beginning of the summer term course and of course the winter term course. So what else? Inputs are as there. So the only thing that we need in addition, of course, to the data is information about the design. So remember that the design matrix in GLM fMRI extends over time, so the rows correspond to time points, and it's based on defining the onsets of different conditions, which are then convolved with the hemodynamic response function. We've actually seen all of this in the beginning of the summer term. Does everyone remember what we did there? 136 clicks were dedicated to that YouTube video. 4 clicks were dedicated to what is actually in the SPM table. But anyway, so should I specify the GLM via the GUI? Who's for specifying the SPM via the GUI first and then turning it into a script? Or should I already start with the script? Who's for GUI? No one. Who's for script? Everyone. Most people don't care, don't know. The other people are not here, so they really don't care. So good. Then let's do this by script. Although that might be harder than I thought, but we have, of course, we have an old script. We only have this one. Let's go again via my so let's, for this, wrong. Better. It's this one. So again, we have some script that somebody else wrote for us, which we can build upon. And let's do that. So, oh, it's not somebody who wrote it. So GLM formulation. Essentially, we need all of this. Event onset functions. So that's the onset. Something else. So this is our model formulation. So let's go with this first. Oh well, let's copy everything and then we go right step by step. So the GLM formulation takes most of the code actually. So that's GLM formulation, model formulation, as we call it up here. So that's all of this code. The estimation takes up very little code. That's just this one here. And yeah, I also follow. I can understand you. And this is the evaluation bit. And again, this was all created via, so these things were created via the GUI manager, yeah?
I have a practical question. So if we adapt the script from somewhere else, do we decide how would you do that?
So the legal situation is as soon as you change a very little thing, you obtain the copyright. Then usually you adapt it from somebody you know, and then yeah, I don't know. It's the thing is, this is also not hard. I mean, everyone can create these kind of scripts. So you could. So if I find scripts that somebody wrote which are not kind of in the open domain per se, then of course I happily write that I adapted from something. If I find a script that is horribly written, does something, but is horribly written and completely messy, and I write it again, then I sometimes put in a note that I adapted it from some other script. This I now adapt from myself, so I don't care. And yeah, and these kind of scripts, they are not really that demanding cognitive creations, because you get them essentially out of SPM directly. The only thing that are cognitively demanding are these kind of comments, because at least there was some effort to understand what's going on. So I don't know. I mean, if you use these scripts for your report, just change something and put in your own name. I mean, all of this is all in the open domain, so it's not that the only thing that I put in my author thing is because I wouldn't do that if then it would not. If I hadn't been told in my life that you didn't do anything. So, because my old supervisor, PhD supervisor, stole the PC, or basically hindered me from accessing all of my work, and then she claimed that there is no name in there. He didn't write anything of that. So now I put my name in there, but it's stupid. It's just because of stupidity in the world that I put my name onto these things. Anyway, whatever. So I don't know. I really don't know, and it doesn't matter. In general, yeah, you can, if you feel like you should. So if you feel like you should pay your respect, then you put something like author Caroline, adapted from something by someone else, something like that. Yeah. But these kind of scripts, they are like the cheapest scripts ever. Good. So, any other questions? It was not really a satisfying answer, but it's hard to answer for these scripts, I feel. Any other questions? No. Good. So, model formulation then is here split up into first directory management thing. So it specifies where the SPM MAT file that is created by the GLM specification should be saved, namely in a GLM directory, which is here called target directory. So we have to adapt that. So we have to do something about that. Maybe let's do that first before we go on. No, maybe not. Let's first have a look what else we need to specify. So we have to specify something about the timing. The units you can specify in either scans or seconds, because SPM needs to know what the units of time is, and here it's specified in seconds, which means that the RT is specified in seconds. So that is actually the TR that we also use, because the script works on the same data. Then this FMIT and FMIT0, that's related to the microtime resolution. Now I really earned my authorship here. Resolution. This is, you can read that in my book, what that really is. So this relates to the way SPM sets up GLM design matrices. These are all default parameters. So these are default parameters, no interactions, no global normalization, no mask. This here, this AR1 is actually something on the covariance parameter for pre-widening. Oops. This is also, you can also find that in my book. Sorry. The one thing is the practical thing, one is the theoretical thing. So we're right now doing the practical thing, which means that we're not doing the theoretical thing. That means we're doing the practical thing, because people like practical things. Really this is about how the covariance components are created, and that's about this. And then we need to specify the data that we want to analyze. Again, this uses the same SPM select logic and specify that. And we need to bring that to, so then we have specified the FMI data, and then we need to bring that together with the onset file. So maybe let's first do these kind of things and stop the whole thing here. So the first thing was that we need to define a target directory where we do this, and we had this pre-directory. So now I want a GLM directory. And maybe we put in, no, we do it differently. We do it the same way as here. It was a little bit premature. We do it the same way here, that we define a target directory, and if this already exists, we delete it. For GLM modeling, if this already exists, we delete it. So that we always start afresh, unless at least when we want to. And then we use it exactly like here. Put it in there. Good, and here we need to now adapt it to what we have right now. Wait, here we have to actually be much more careful, because we need, here I had everything for just one run in one folder, but here we now need to specify the scenario that we actually have multiple sessions. So we have to basically continue where we left off with the pre-processing. So we take the smooth ones, and then we need to check, I think it comes in there. So remember that session and scans, sessions are runs in SPM, and non-specific data. So this we don't need, because we're doing that there. And let's have a look how far we get with that. Something wrong with the function. And doesn't, the first function might not have meant. What is wrong with the function? Let's comment this out. That looks better. We have an input specified. this would be, okay, so part D, how do we define that here? Pre-processing, but now we, okay, so we have to be actually much more specific here. Good, let's have a look. Again, the problem is just getting the, oops, in the wrong script, sorry. The problem is just getting the data specifications right. So that's there. We now have to specify, of course, the run directory, which is there. Then it's in pre, and then I have to take a look. Then it's in run something. Sorry. That doesn't look too bad. And then let's see whether that works. We can actually test this way. Run there doesn't work. So we need actually this, so maybe we give this name so it doesn't look that long. Doesn't really work anyway. That should be run there. So this is again where I get hungry. Let's see how we go with this. Oh, there's something missing that doesn't say which participant it is. Just guessing now here. It's also not good. So data 12DO pre-run. So let's then test these two here. Yeah, so this way it will find the data from this session and then it allocates it. So far so good. But we cannot execute this job yet because we have to specify the onset and some additional stuff before we can actually formalize the GLM. And this is actually the other point where something that you acquired at the scanner comes into play. So we had here these files with a lot of stuff in there. Which have something in there. How did I do it? I think I actually might have done that. So this has the event log in it. So this is in seconds. Experiment experiment start at time 0, and then there was fixation. Condition 2, there was slow checkerboard contrast. Condition 1, target on, and then button press. Of course, you only know really these things. So there are two things to say about these things. So first of all, there's now the bits format for coding events in a standardized format, so that it is the same information as you have in this event log, but in a more standardized fashion. This is one thing that is good about bits. And what else? I think I also, for previous analysis, already extracted the relevant information. Target. No, target. No. Because I have the correct file obviously here. Or not correct file, that's another file. There. So this is actually something which you need to take care of in some way. Let's first look what we know I did there. Yes, this is also what I remember. So this has the onsets for the first condition and the second condition in the first two entries, and then it has button presses here, and that was something else. So, but this is of course only for a single session. So somewhere in the files there was a conversion of the original stuff that was saved into these onsets, although I think I actually saved also this thing as that. In any case, this shows you again how important bits format is, so that I don't teach you the idiosyncrasies of how I did it in this experiment, and some other people might do it differently in different experiments, but we all, as the great brain mapping community, we all do it the same way with respect to our events. So this is obviously also a task for your project report, so that you get really into that. So one thing that we can do is...
but from which variables did you extract these onsets though?
Yeah, I think I will do that for you so that you don't have to go into that. I think it was from the event log, but I think this also has some variable which name I can't remember that actually looks like this. No. No. No, that's I think something else. I think it's this I. No, that's the response array. Yeah, I will look into it and tell you next time. That's faster than doing it now. So the question is, so this is obviously because on what I have in this other project, I'm doing it only for a single run. So here we might have multiple runs. So let's call this one onsets. And then the question is where you save them. And I would these days actually recommend to have them with the FMI data. So I'm putting them in here. So this is something, of course, you need to, in real life now with bits, if you have the data in bits, then you have the raw data and that has the FMI data, the MI data, in a folder together with the event file, which is this run onsets file. So if you follow the bit standard, the way I'm doing it right now is essentially the standard way, but what do I want to say? Don't know. Yeah, just work yourself into bits, and then you know where you actually need to put the event file, and then you are fine. It's really, really simple. It is actually really simple. So let's then just make sure that, oops, oh, have a nice safety test, the new name. Now I'm running out of time again. No. Let's see whether we get that in the last minutes. So we are in this folder. No, we have to actually do this for each. So we have to specify, because we are in principle have multiple runs. We put this there. Now we need to load, so this is where we went up to, so this is what we had done already. Now we need to load the onset event file, which ideally would be there in bits, but right now it's in kind of a semi-bits thing. It is in the run directory, because I just put it there, and it's called onsets run something. Now they're trying this out again. So we have to stop. This is really what I hate when I program and then I have a meeting. It's kind of the worst thing because you get nothing done. So now you're really into it, know what you're doing, and just need to finish, and then you have to have a meeting. And it's like, what? Why do I have to have a meeting now? Anyway, we stop here and continue at that point next week.